absolute value inequalities. So we're dealing with the absolute value symbol and greater than or less than, greater than or equal to, less than or equal to symbols. So I'm going to give some definitions first, and then we'll do a couple examples, talk about why these make sense. For a is greater than 0, absolute value of x is less than a means negative a is less than x is less than a. And then absolute value of x is greater than a means x is less than negative a or x is greater than a. And we'll do some more what if it's not greater than 0, and then each of these. So one thing I'll note though is less than works the same as less than or equal to. Greater than, same as greater than or equal to. I just don't have the or equal to's on these ones. And just like with equations, with absolute value, we need to isolate the absolute value part first before we use these rules. Like this one. Let's say absolute value of x plus 3 plus 1 is less than 5. So first, I'm going to subtract the 1 over absolute value of x plus 3 is less than 4. Okay, so if I use the rule, this is saying that, whatever this is, it's between negative 4 and positive 4. So if I solve this, subtract 3, I'll have negative 7 is less than x is less than 1. So I always like to do these on a number line to see if my answer makes sense. Because what I'm saying is x is between these numbers, and I'll use parentheses between them. Shade in between, but let's do a little check. So how about 0? Let's check 0 in between. This should work. Absolute value of 0 plus 3 plus 1, is that less than 5? 3 plus 1 is 4, yes, that is less than 5. Now if I try out here, let's say 2, absolute value of 2 plus 3 plus 1, is that less than 5? Well, that's me 5 plus 1 is 6, is not less than 5. Or if I try something over here like negative 8, absolute value of negative 8 plus 3 plus 1 is less than 5. That's mean negative 5, absolute value is a positive 5, 6 is not less than 5. So I know I got it. And my interval notation for this would be negative 7 comma 1. So anything between negative 7 and 1. So that's a less than. Notice less than. Greater than is going to be different. We'll leave our definition up. About absolute value of x minus 1 is greater than 4. Okay, so if I follow this directly, then I'm going to say, let's throw an or equal to it. X minus 1 is less than or equal to negative 4, or x minus 1 is greater than or equal to positive 4. So basically, it's like the positive one, and when I drop this, we solve our normal inequality. For the negative one, we flip the sign around, which kind of makes sense because when you multiply or divide by a negative, then you reverse the inequality sign. So hopefully that kind of makes sense. Same with this one. It's like the positive one is how it was originally. The negative one, the sign gets flipped around. Okay, so that means if I add 1, x is less than or equal to negative 3, or x is greater than or equal to 5. So again, let's jot this on a number line and see if it makes sense. So x is less than or equal to negative 3. That means going to the left, less than. And then 5. X is greater than or equal to 5, going this way. So let's check a few numbers. Let's check negative 4. Absolute value of negative 4 minus 1. Is that greater than or equal to 4? Well, that's negative 5. Absolute value of negative 5 is 5. Yes, that works. How about 0? 0 minus 1. Is that greater than 4? No. 1 is not greater than 4. And then let's try 6. 6 minus 1 is 5. Is that greater than or equal to 4? Yes. Okay, so it's like my ends work, but not my middle ones, because if it's a smaller number here, it's not going to be big enough to be greater than or equal to 4. So my interval notation would be negative infinity until negative 3, bracket, union 5 to infinity. Okay, so then both of those, we did one of each of these, both with this number being positive, the a being positive. So let's see though if what happens when we have a is less than 0. You know, let's add some rules to this. So let's see. So I'm just going to switch this around. For a is less than 0. Let's see what happens when its absolute value of x is less than a versus absolute value of x is greater than a. So how about absolute value of x plus 4 is less than negative 3. Now let's just think about it. What's happening here? This is a positive number, no matter what I do, because it's absolute value. When is a positive less than a negative? When is a positive less than a negative? Never. This never happens. So that means there is no solution. I could plug in, you know, any number. Let's say 0, we'll do 5, and negative 5. Negative 5 plus 5 is negative 1. That's going to be 1. That is not true. 0 is 4 less than negative 3? No. 5 plus 4 is 9 less than negative 3? No. Never going to happen because these are all positives. So it would be no solution. No solution. Because a positive is never less than a negative. Okay. How about the other way? When is the absolute value of x plus 5 greater than negative 1? So now, again, this is, just think of it. Well, no matter what, this is a positive. When is a positive greater than a negative? Always. Again, let's kind of think about this. 0, let's just do negative 5 and 5 again. How about negative 5 plus 5? That's 0. Is 0 greater than negative 1? Yes. 0 plus 5. Is 5 greater than negative 1? Yes. 5 plus 5 is 10. Is 10 greater than negative 1? Yes. Yes, yes. No matter what, this is going to be a positive. It's always going to be greater than a negative. So it would be all real numbers or negative infinity to infinity. All real numbers are going to work.